Kia ora. Let's now look at the hydrolysis of polyamides. Now, again, with polyamides, we can hydrolyze them under acidic and basic conditions. So hydrolysis means, of course, adding on an H2O. So the first thing you do is you look for the peptide link. And the OH of the water goes onto the carbonyl carbon, and the other H of the water goes onto the amine group. So here are my products. So this is this product over here, and my other product is this one over there. So all I've done is I've split it, added an OH, and added to this one an H. But now you'll see, well, what else have I added on? I've added an extra H to there into there. And that's because an amine group, whenever I make an amine group, if I've got extra hydronium ions present, they will just undergo a normal acid-base reaction and they will protonate. So if you know the anion of the acid, you can include it. Otherwise, you can just ignore the Cl- and just simply draw this with a protonated nitrogen in each case. Under basic conditions, I form very similar products. I do the same thing. I break it, add the OH to the carbonyl and the H to the N. So there you can see I've added my OH to that carbonyl and my H to this N over here. I should have done it in a different color. But now it's not exactly the same because where's the OH? And again, the OH are formed being acidic will react with the excess base, and I'll form then the normal acid-base reaction to form a salt. I form the carboxylate salt. If I know the cation of the base, I can include it. If I don't, if you're just told it's under basic conditions, you just leave out the cation and you just simply draw this with any COOH having the H removed and a negative charge. Don't forget to draw your charges. The positive charge on the nitrogen, you can see the nitrogen has got 4 bonds, so it must be protonated. And here the oxygen is only 1 bond, so it must have a negative charge. So here's an example. Pause the video, try and work out the product under acidic conditions and base conditions for hydrolysis. So here's the answer. You look for the peptide link, of course, and you'll see that this is identical to that. So we've only got 1 monomer. And here it is. You can see all I have done is I've added an OH to this carbon. And it's under acidic conditions, so that doesn't react further. But my amine, my NH, does react further with the extra acid. So I will have it protonated with a positive charge on it. Under base conditions, I do exactly the same thing, but now my amine being basic doesn't react further with the excess base, but my COOH being acidic does react, so that acidic hydrogen is removed, and so I have a negative charge on the oxygen. So this oxygen only has 1 bond with a negative charge. That nitrogen has got 4 bonds with a positive charge. Kia ora.